we will evaluate the inverse secant function values using the reference triangles shown here below, where each inverse secant function value is equal to an angle in the closed interval from 0 to pi radians, not including pi over 2 radians, which means in standard position, each angle will be, again, from 0 to pi radians, not including pi over 2 radians, which means the angle will be in this interval here. And since secant theta is equal to the reciprocal of cosine theta, secant theta is positive in the first quadrant and negative in the second quadrant. The first expression is inverse secant of negative 2 square root 3 divided by 3. Looking at the reference triangles, we should be able to recognize we'll be using the 30, 60, 90 reference triangle to evaluate this because of the square root 3 in the given secant function value. But it will be helpful to rationalize the numerator to make it easier to recognize the angle we will use to evaluate the given expression. So let's begin by rationalizing the numerator of negative 2 square root 3 divided by 3. To do this, we multiply the numerator and denominator by the square root of 3. This gives us negative 6 divided by 3 square root 3. The 3 and the 6 simplify. There's 1 3 and 3 and 2 3s and 6. This simplifies to negative 2 divided by square root 3, which means you can rewrite the given expression as inverse secant of negative 2 divided by square root 3. Now we will ignore the negative for a moment and determine which angle in the reference triangles gives us a secant function value of 2 divided by square root 3. So again, looking at the 30, 60, 90 reference triangle, notice how the secant of 30 degrees, or pi divided by 6 radians, again is equal to the ratio of the hypotenuse to the adjacent side, which is 2 divided by square root 3. But we are looking for the angle that has a secant function value of negative 2 divided by square root 3, and therefore the angle we are looking for is not 30 degrees or pi divided by 6 radians, but this is the reference angle that we will sketch in the second quadrant where we know secant theta is negative to find the angle that we want in this given interval. So the next step is to sketch a reference angle of 30 degrees or pi over 6 radians in the second quadrant. This will be the terminal side of the angle we are looking for, where again this reference angle is 30 degrees or pi divided by 6 radians. And now let's sketch the reference triangle, which is this right triangle here. Because we are in the second quadrant, x is negative and y is positive, and therefore we label the opposite side 1, the hypotenuse 2, and this leg here would be negative square root 3 because x is negative. Notice how this reference triangle does give us a secant function value of 2 divided by negative square root 3, which does match the given secant function value in either form. Which means the angle we are looking for has its initial side along the positive x-axis as always, and the terminal side must be this ray here, rotating counterclockwise. The angle in this interval that has a secant function value of negative 2 divided by square root 3 is 150 degrees or 5/6 pi radians, which we can determine by taking 180 degrees and subtracting the reference angle of 30 degrees, or pi radians, and subtracting pi over 6 or 1/6 pi radians. And therefore inverse secant of negative 2 divided by square root 3 is equal to 150 degrees or 5/6 pi radians. Next we have inverse secant of negative square root 2. It may be helpful to write negative square root 2 as a fraction with the denominator of 1. This is equal to inverse secant of negative square root 2 divided by 1. And again, because the given secant function value is negative, we ignore the negative sign for a moment and using the reference triangles, determine which angle has a secant function value of positive square root 2 divided by 1. We're looking at the 45, 45, 90 reference triangle. Notice how the secant of 45 degrees, or pi over 4 radians, again is equal to the ratio of the hypotenuse to the adjacent side, which does give us square root 2 divided by 1. And since we are looking for the angle that has a secant function value of negative square root 2 divided by 1, this is not the angle we are looking for, but this is the reference angle in the second quadrant we can use to find the angle we are looking for. So now we sketch a 45-degree reference angle in the second quadrant, and therefore this is the terminal side of the angle we want, where again the reference angle, this angle here, is 45 degrees or pi divided by 4 radians. Let's sketch the reference triangle. Again, we are in the second quadrant where x is negative and y is positive, and therefore this leg is 1, this leg is negative 1, and the hypotenuse is square root 2. Again, notice how this reference triangle does give a secant function value of square root 2 divided by negative 1, which is the same as the given secant function value. The angle we are looking for has its initial side along the positive x-axis, its terminal side along this ray. Rotating counterclockwise, the angle we are looking for in the closed interval from 0 to pi radians is 135 degrees, or 3/4 pi radians, which again we can determine by taking 180 degrees and subtracting the reference angle of 45 degrees, or pi radians, and subtracting pi over 4, 1/4 pi radians, which gives us 3/4 pi radians. Inverse secant of negative square root 2 is equal to 135 degrees, or 1/4 pi radians. Next we have inverse secant of 2, which is equal to inverse secant of 2 over 1. Looking at the reference triangles, notice the secant of 60 degrees, or pi over 3 radians, is equal to the ratio of the hypotenuse to the adjacent side, which is 2 divided by 1, or 2. And since the given secant function value is positive, the angle we are looking for is 60 degrees, or in radians, pi over 3, or 1/3 pi radians. So notice how when the secant function value is positive, we don't have to sketch the reference angle or the reference triangle, but let's go ahead and show it anyway. We would sketch a 60-degree reference angle in the first quadrant, and therefore this is the terminal side of the angle we are looking for, where this reference angle is 60 degrees, or pi divided by 3 radians. And now let's sketch the reference triangle. We are in the first quadrant where both x and y are positive, and therefore both legs are positive. We have 1, 2, square root 3. Notice this reference triangle does give a secant function value of 2 divided by 1, and therefore the initial side is along the positive x-axis. The terminal side is along this ray. Rotating counterclockwise, notice how the angle we are looking for is the same as the reference angle of 60 degrees, or in radians, 1/3 pi radians. And now for the last example, we have inverse secant of 1. To evaluate this, we will not be able to use a reference triangle. We will have to use a unit circle or our knowledge of the graph of the secant function. Remember, secant theta is the reciprocal of cosine theta, and on the unit circle, x equals cosine theta, and therefore on the unit circle, secant theta is equal to the reciprocal of x, or 1 divided by x, which means we are looking for the value of x on the unit circle in this interval, where 1 divided by x is equal to positive 1, which is this point here with the ordered pair 1, 0. Again, when x is 1, the secant function value is 1 divided by 1, or just 1, which means the terminal side and the initial side of the angle we are looking for are both along the positive x-axis, and therefore the angle is 0 degrees, or 0 radians. Another way to evaluate this would be to look at the graph of the secant function only on the closed interval from 0 to pi radians and determine the angle for which the secant function value is 1. So here we have the graph of the secant function in blue. Notice in red we have the graph of the cosine function. If we focus on the interval from 0 to pi radians, highlighted here in yellow, notice how the secant function value is 1 at this point here in the interval from 0 to pi radians, and the corresponding angle is 0 degrees, or 0 radians. I hope you found this helpful.